Forget the Mariana Trench. While it may hold the ultimate record for depth, there is another, far more dangerous abyss lurking in the Pacific, a 34,580-foot chasm that sits not in isolated waters, but directly on one of the most active fault lines on the planet. This is the Philippine Trench, the third deepest place on Earth. And unlike its famous cousin, it is a sleeping giant that is critically overdue for a catastrophic awakening. This trench has generated multiple magnitude 8.0 plus earthquakes and devastating tsunamis in living memory, and it sits directly adjacent to a population of over 100 million people today. We embark on an ambitious journey to uncover the terrifying secret of the Philippine Trench, a mega-quake threat that is not a question of if, but when, and whose eventual rupture will send shockwaves, literal and figurative, across the entire Pacific Rim. To truly grasp the Philippine Trench, we must first comprehend its sheer scale. Running for approximately 1,400 kilometers, around 870 miles, along the eastern edge of the Philippine archipelago, this subduction zone is a colossal scar in the Earth's crust. Its deepest point, known as the Galathea Deep, or Emden Deep, plunges an astonishing 10,540 meters, or 34,580 feet below sea level. To put that into perspective, if you inverted Mount Everest and placed it in the deepest part of the Philippine Trench, its summit would still be more than a mile below the ocean's surface. That is a truly incomprehensible depth, but the trench is more than just a deep hole. It's a dynamic, active geological engine. It was formed by one of the most violent and fundamental processes on Earth, subduction. Here, the massive, dense oceanic crust of the Philippine sea plate is relentlessly diving or subducting beneath the lighter, overriding Eurasian plate. This titanic collision is not a gentle glide. It's a grinding, frictional battle of continental proportions. The rate of this subduction is staggering, approximately 7 to 9 centimeters, around 3 to 3.5 inches per year. While that might sound slow over decades and centuries, this continuous motion accumulates an enormous amount of stress. It's like slowly but inexorably coiling a colossal spring, tighter and tighter. Eventually, the friction holding the plates together can no longer withstand the immense pressure. The plates suddenly slip, releasing centuries of stored elastic energy in a matter of seconds. This is the birth of a megathrust earthquake, the most powerful type of seismic event known to science. Unlike the Mariana Trench, which is largely inactive due to its older, colder plate, the Philippine Trench is seismically hyperactive, clear and present danger to millions. The Philippine Trench isn't just a theoretical threat. Its history is written in disaster. It has a well-documented past of generating colossal earthquakes and devastating tsunamis, proving its immense destructive potential. Consider the 1918 Celebes Sea earthquake, a staggering magnitude 8.3 event. While the technical fault mechanism is debated, it occurred within the broader tectonic framework driven by the Philippine Trench's activity, demonstrating the sheer power of this region. More recently, and far more tragically, was the 1976 Moro Gulf earthquake. On August 17, 1976, this section of the subduction system ruptured with a magnitude 8.1 earthquake. While the shaking was severe, it was the ensuing tsunami that unleashed unimaginable horror. A colossal wave, up to 5 meters, 16 feet high, slammed into the coastal communities around the Moro Gulf, particularly Mindanao. With no warning systems in place, and striking in the middle of the night, the death toll spiraled to over 8,000 people. This remains the deadliest tsunami in modern Philippine history, a grim testament to the trench's power. Even in recent memory, the trench has reminded us of its capability. The 2012 Samar earthquake, a powerful magnitude 7.6, struck along the Philippine Trench, off the coast of eastern Samar, although it caused limited damage on land. It generated a local tsunami that affected coastal areas, serving as a stark reminder that even smaller major quakes from the trench can produce devastating waves. Geologists study these historical patterns for a reason. They reveal recurrence intervals and highlight seismic gaps. A seismic gap is a segment of an active fault that has not experienced a major earthquake for a long time, even though other segments have been active. This indicates that stress is accumulating in that particular segment, making it critically overdue for a rupture. The Philippine Trench has several such segments, particularly along its central and southern portions, that have not seen a major megathrust event in centuries. The continuous, smaller magnitude 6 and 7 quakes we see every year are not releasing this deep, accumulated pressure. They are merely reminders that the system is active, and the big one is still building in the silence. A megathrust rupture in the Philippine Trench today would unleash a double-edged sword of destruction: catastrophic ground shaking and a devastating tsunami. First, the ground shaking. A magnitude 8.0 earthquake would be felt across the entire Philippine archipelago, causing immense damage to infrastructure across multiple islands. Buildings not designed to withstand such forces would crumble. Massive landslides would be triggered in mountainous regions, blocking vital roads and isolating communities. In coastal cities built on reclaimed land, like parts of Metro Manila, though more directly threatened by the Manila Trench, the Philippine Trench still impacts its stress field. Widespread liquefaction could occur, where solid ground turns to a liquid mud, causing structures to sink or collapse. The economic and human cost from the shaking alone would be staggering. Second, and perhaps even more terrifying, is the tsunami. Because the Philippine Trench is so deep and runs so incredibly close to the eastern coasts of Samar, Leyte, and Mindanao, the warning time would be catastrophically short. A rupture would vertically displace a colossal column of water, miles high and miles wide. This would send a tsunami wave crashing into the nearest shorelines in as little as 10 to 15 minutes. This is not enough time for official warnings to reach everyone, or for widespread, organized evacuations. Coastal communities would need to rely on immediate, spontaneous evacuation, based on feeling the strong, prolonged earthquake shaking. The reach of such a tsunami would not be confined to the Philippines. The energy would radiate across the entire Pacific Ocean. Models show that a major Philippine Trench tsunami could threaten the coastlines of Japan, Taiwan, Indonesia, and potentially even the west coast of the United States and Canada, though with much reduced wave heights and significantly longer warning times. Nevertheless, the scale of potential impact is global. Over 100 million people live in the direct path of its immediate impact zone in the Philippines alone. The devastation would dwarf any previous disaster. Venturing into the deepest part of the Philippine Trench, the Galathea, or Emden Deep, takes us into the Hadal zone, a realm of eternal darkness, crushing pressure and freezing temperatures. Here, the water is barely above freezing, and the pressure exceeds 1,000 atmospheres, or 15,000 pounds per square inch. It's a pressure so immense it would instantly flatten a human body. Yet, life thrives in this alien world. Scientists using specialized deep-sea submersibles have discovered unique, highly adapted organisms. These include giant amphipods, translucent fish, and bizarre invertebrates that survive not on sunlight, but on chemosynthetic processes, extracting energy from chemicals released from hydrothermal vents and decaying matter. These creatures are testament to life's incredible resilience, pushing the boundaries of what we thought was possible. However, even this remote, extreme environment is not immune to human impact. Expeditions by explorers like Victor Vescevo have sadly documented the presence of plastic waste, even at these staggering depths. Our footprint reaches even into the planet's most pristine and inaccessible places. Beyond pollution, the trench is also being eyed for its potential mineral wealth. Deep-sea mining corporations are exploring the possibility of extracting rare earth elements and other valuable minerals from the trench's floor. The environmental implications of such operations are massive and deeply concerning. Disturbing these unique, undiscovered ecosystems, which often grow at an incredibly slow rate, could cause irreversible damage before we even fully understand what we are destroying. The ethical debate surrounding deep-sea mining in such sensitive and critical geological zones is intensifying. The Philippine Trench remains one of Earth's most dangerous and least understood features. We arguably know more about the surface of Mars than we do about this abyssal trench right in our backyard. While scientists are making incredible strides in monitoring and research, we are undoubtedly in a race against time. The Philippine Institute of Volcanology and Seismology, PhilippineTrench, operates a network of seismic sensors across the archipelago, providing crucial real-time data. International collaborations, including with the Pacific Tsunami Warning Center, PTWC, help improve tsunami detection and modeling. Deep ocean assessment and reporting of tsunami dart buoys are deployed in the broader Pacific to detect tsunami waves in the open ocean, providing precious hours of warning for distant shores, though offering little relief for the immediate Philippine coast. However, significant challenges remain. The sheer length and depth of the trench make comprehensive, continuous monitoring incredibly complex and expensive. We still lack detailed bathymetric maps for vast sections of the trench, meaning we don't fully understand the complex faulting and potential landslide triggers hidden in its depths. Investing in more advanced deep-sea observatories, remotely operated vehicles, ROVs, and high-resolution sonar mapping is crucial. Ultimately, we cannot predict when the next Mega-Quake will strike along the Philippine Trench, only that it is inevitable. The trench is a sleeping giant, and the silence in its depths is the sound of pressure building. The lessons from 1976 and 2012 are stark reminders of the rapid onset of disaster. For the millions living along the Philippine eastern seaboard, preparedness is paramount. Understanding the warning signs, prolonged shaking, and having a clear, practiced evacuation plan to higher ground within minutes are their best defenses. This deep, active, and terrifying feature of our planet continues to test humanity's resilience and scientific ingenuity. If you believe understanding this powerful geological threat is vital, hit that like button to spread the awareness and to stay informed on the secrets that lurk beneath our feet. Subscribe to baytube right now. We'll see you in the next deep dive.